Hello, John here again, and this is part 6, I think. Part 6 of the OSK monitor, or the machine code monitor. And if you remember in the previous video, I had a problem with Hunt, that it was not finding the search criteria. That was, it seemed to find the basic word, but then when I went and looking for syntax, it couldn't find it, or any other word for that. Well, I figured out what the issue was, and it was where are we? So the way it does it, right, is it gets from the keyboard and stores it in that context. Then, when it's finished, it starts hunting for it. So it starts at the very first line and then compares it with context. And if it's not equal, yeah, if it's not equal, it continues. So it adds 1 to the conv vector, does that, and then goes back round. So it does here, so it goes back round. So it goes to here and it tests to see if it's hit the end. And then it comes back round, but when it starts equaling it, it goes to here. So it increases y, compares y with the number of characters we've got, and if it's not equal, goes back round, tests again, finds another one, finds another one, finds another one. And then what was happening was, it was here when it was doing the adds. You know, when it does this add here, this command here was there on before hung 6, so it was always comparing a number that we didn't know about, and that's what was happening. It was jumping out too early. So just to show you that it's working, so I'm going to do the same thing as we did before. So here's the machine code monitor, so start it up. And here we go. So hunt A1000 to C1000, and we're looking for the word basic. There you go, A007, which is what it used to do. So this time we was trying to find the word syntax. Yeah. There you are, A235. So we'll try the word file. Now we know there's a few instances of the word file in the ROM, so we should find multiples. And there you go. There's an instance at A1A7, A1AC, A1B5, A1C2, A207, A2E4. So that's Hunt finally working, and just because I put the label in the wrong place. Oh well, we live and learn. Anyway, shall we continue? So that was Hunt. That was just to let you know that I got it working. So the next thing I've put in is load. So this basically loads a file from a device into memory. And so the way we're doing it here is first we get the character, and we reset the character counter, and the first character normally is a space, so we just leave it, and then we start getting the character, compare it with a quote. If it's equal to a quote, it starts copying the file name into the store. Well, no, if it equals a quote, then it's gonna, that means it's copied the file name into the store here, and we've got a maximum of 16 characters, and if it carries on going, we jump to an error. Alright, but if it finds the quote at the end, then it stores the length of the file name, and then gets a single byte after that, which is the device number, and then transfers that into the X register. So we load Y, A and Y with 1 and whatever the device number is, and then we set up the logical file structure. We print a carry to return line field, so we're dropping down a line. We load the length of the file name and the position, and then we set up the name. Then we load the accumulator with 0. Now when you use the load function, if 0 means load, 1 means verify, and then we perform the load. We jump to the load jump vector, and that will perform the load, and then that's finished in with the ready. So it just prompts you with ready. So let's do a quick do that. I'm not sure. Oops, fired it from the wrong place again. Not sure if I've got a file available to test this out, but we'll see. We'll see what we've got. Right, so new load. Right, so we haven't got a file there, so I'm going to attach one of my disks, and what should we attach? We will attach that one there, O2. So we're going to load the O2 program. So we're going to load O2 star. Right. Okay, so load O2 star space 08. There we go, done. Now that should have put it in C1000. So what we're going to do, we're going to fire up the monitor, and we're going to look in this disassembler to see if there's any instructions in D1000 at C1000. And there you go, there is. And that's my old school assembler that I wrote when I was a kid, which I will be doing a video on soon because I've nearly converted it into this. So that's the load program, and it, like I say, it loads, but I was trying to find something that wouldn't overwrite the machine code monitor. The next subroutine is memory, where it displays the memory, and the command for this is M address and address, so start and end address. So the way it does is it gets the first 2-byte hex number and stores it in add vector. Then it gets the end hex address and then stores that in disend, and then basically just runs through it. So this is setting up the line. Yep, so this is setting up the line. So this is because there's going to be 10 numbers on every line. So it runs through, and mem1 adds the 10 to the working vector and then compares it with the end vector, and if it's not equal, goes back, sets up another line. If it is equal, then we test the low byte to see if that's hit it, and if it has hit it, it jumps to mem4. If it hasn't hit it, it goes back to here, and mem4 is just jumping to ready. And then we've got the printing of the line and the adding of the adding the offset to the data, and then we've got the action for memory put, which allows you to take what is displayed on the memory function and apply it back. So what then, that is address, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes. So we get the address, store it away, and then we run through until we hit a return. And every time we hit a return, when we hit the return, we jump out. So to ready. So, and this allows then to store what we put back on the state. So if it doesn't hit a return, it jumps to here and then gets a byte. We load the index and then store it in the vector comma the index and increase the index by 1 and store it away, and then we test to see if it's at 10. So we're gonna do this. So I start it again. So memory, let's do memory 400 to 0440. So this is doing the screen. There you go. So that's the screen. So OF, OC, blah blah blah, and this is showing it. So we've got some. So I better do it again because those spaces are now populated. No spaces. Okay. So what we're going to do is we're going to change a couple of these bytes. So we're going to put 01, 02, 03. Press enter. And there you go. And it's done it at the top here. So 0428, which is the line. 01, 02, 03. Now, can you see there's a problem? Because it's putting pluses in there, so we need to figure out what's happening there on the memory put, because it should be put in 01, 02, 03, which should be A, B and C. So we need to work out what's going on. So what we'll do is here we'll put 00, 00, 00, 00, 00, 00, 00, 00, and see what's right. So it's not interpreting those bytes properly. So it's doing the 10, but they're not right. So let's go back in and find out why it's doing it. Memory put. So we're doing the input command. Is it return? No. I wonder. So we get the first byte, and then we get the second byte. Okay, let's change that. Maybe I'm using the wrong input command. We'll change that to character in. And then we'll save it and then we'll try it again. So memory 0400 to 0440. So we're in the same place. So 0420. So we're going to put 01, 02, 03. There's something a bit more sinister going on here. Very sinister. Space. Uh-oh. Right. Okay. I will figure that out and I'll give you the results in the next video. But that displays the memory, and then the final one is output. Now I can't demonstrate this one because it requires a printer, but basically what you do is you just put O and then Y or N. So Y means you're going to send all the output to the printer, and then N means you're going to stop it. So what we do is we find the command and then we compare it with Y, and if it's Y, we're setting up the output channel to the printer, which is here. So we're saying load 4, device 4, which is the printer, transfer it into the X, so it's going to be a secondary we're going to load 4 as the file number, then transfer it into X for the device number. So we open it, so it's very similar to saying open 4,4, and then we put 255 in because that means nothing. Set up the logical file, set up the name, which is nothing, because with a printer you don't need a file name, and then we open it, and then we set the output channel to be on file 4, and then that's it. So everything will then go to, every output will then go to the printer, so you won't see it on the screen. And then if we do no, then basically what we're doing is saying we're clearing the channel, and then we closing file 4 and then send it on its way. So they're the next. So I've fixed the hunt, and then I've just added 3 more commands. So I'm now going to, after this video, I'm going to figure out why it's not working the memory put, and I will then, in the next video, when I show you the next set of commands I've done, I will show you how I fixed it, because I think it's just evaluating the hex number wrong. So I will leave you with that, and I'll see you in the next video. Take care. Bye. Hello. This is just an add-on to the video I've just done. I literally stopped the screen capture and then realised what an idiot I was. And the problem with the memory put was I was actually calling the wrong subroutine. So what I've done is, as you can see, I've put it back to input command, because the input command filters out some characters and stuff like that. And it was this routine here. I just put iByte and forgot the 1, when in fact I need to do iByte 1 plus 3. And so basically, instead of calling this routine and starting here, right, because this is 1, 2, 3 bytes, it was starting down here and then doing 1, 2, 3, and so it was all screwed up. So I'm just going to show you, and I'm going to just prove to you that it's working now, because literally as I just stopped the video I thought, why am I calling that? That's not right. So here we go. So I'm going to do what I was doing before. So memory 0400 to 0440, and starting at 28, because that's the line, and I was putting in 01, 02, 03, and just for good measure 04. Press enter. There you go. So the memory placement is now working. I mean, it's just silly things like that that really annoy you. But you know, I literally spotted it straight away. So I'm going to put all this all the code up onto GitHub, so you can all download it and have a play with it. Give me a thumbs up if you think I warrant it, a thumbs down for all the mistakes maybe, but please comment, and I will answer, you know, every comment that I see. So with that, I'll see you in the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.
You can't handle the truth.